All right, so we're doing section 3.6. There's only two examples. It's kind of stuff that we've done before, but they're going to add an extra twist to it. So we're going to do three variables instead of two. Remember we had to do substitution elimination? Remember that stuff? All right, that's what we're doing, but we're not doing it just with two variables, x and y. We're doing it with three. All right, x, y, and what else? Z. I'm actually skipping the first example, so we're just going to go right to example 2. Chandler, please don't do that. All right, so here we go. We're going to go right with the example. I'll just teach it while I'm doing the example. So write this down. It's supposed to be a minus. It's kind of small, but... And then one more.
Is that 2z?
I've been writing z's like that all year long. Yes.
What would be like the real life thing for this? Would it just be like the snowboard and then another fancy one?
Like for this? I couldn't. I can't really give you one. This is three-dimensional. I'm terrible at drawing three-dimensional things, okay? So that's why we skipped example 1, because they asked you to graph it. But they asked you to graph a three-dimensional thing on two-dimensional paper, which is very difficult. So I just skipped that. But the z is the third dimension. You got x, y, and z. So x would be going, like for instance, if you take a corner of a room, okay? So see where it meets at the very top corner right there? So the one going horizontally would be your x-axis. It keeps on going, right? I mean, it stops there, but it would keep on going. Then the y would be the one up against the wall, right? Okay, where they come together. And the z would be the one coming out of it, all right? So you actually have points that aren't just in a flat surface. You have points that are in three dimensions. So like if I said this point right here, bam, what would that be? Well, it would be over the x, up the y, and then out the z. And that point would be located here. Does that make sense? So it's the same thing, except we're just dealing with three-dimensional objects. They have some pictures in there with some planes, 3D. They have them intersecting. They have them not intersecting and all that. So I'll leave that up to you to look at it to see, like where this comes from. But that's what's going on. Okay, we're talking three dimensions, and really life is full of three dimensions. Not everything is on a flat surface. Would you agree? Yeah, stuff's out here. You build a building, it's three-dimensional, all right? Anything, pretty much, you build is three-dimensional. So that's why we use this stuff, because people use three-dimensional things all the time. There's points out here in space, and that's what it would be. All right? Yes.
What's 4D?
There's really no 4D. Okay, so let's do this. So what we're going to do is we're going to use a combination of substitution and elimination, depending on which one works the best. And I'm not going to say do this. Now, I promise on this one. Remember before I said I wasn't going to say, you have to do this by substitution or elimination. But when I gave you the review for the quiz, remember that? I said, yeah, I am going to tell you use substitution for this and elimination for this. But on this one, it's such a combination, depending on the problem, that you just use what you think works the best. The way they set this up actually fairly simple. Okay, this is not a very complicated one. It's one of the easier versions of this, just because of the equations that they gave you and the way they set it up. So here's something that I might have been taught this in high school, but I never remember learning it until I got to college. And I remember a professor saying, if you're solving for three variables, you must have three equations to be able to solve for it. I cannot just, like if I didn't have this bottom equation, there's no way I could solve for x, y, and z. Everybody follow me on that? All right, you have to have three equations. If you have three variables, you have to have three equations. All right, that's something that for some reason, it just hit me when I got to college. I was like, wow, I never even thought about that. Maybe a teacher did tell me that in high school. I don't know. But I just remember in college some professor saying that. I was like, oh, okay, that makes sense now. right? So if you got 3 variables, how many equations do you have to have? 3. If you have 2 variables, you need how many? Just 2 equations. If you're just solving for 1 variable, you can just solve for x just with 1 equation, can't you? Yeah. All right, if that's your only variable. All right. So let's do this. Let's take a look. And we're going to go back to our knowledge of substitution elimination with just 2 variables, and it's going to work pretty well. So what do you think, just by looking at it, what do you think we want to, I'll give it to you right now. We're going to eliminate something. That's the easiest thing to do. Okay. I mean, you could actually do substitution. You could get x by itself, right? Move this to the other side and then substitute it in for this x. You could do that. I wouldn't in this situation. In this particular situation, they rigged this thing, didn't they? They rigged it to make it really easy for you. So what makes this thing really easy? The y's, exactly. I got a plus y and a minus y, okay? But I also have a plus y down here and this minus y. Agreed? So it doesn't matter which one you use. I'm going to use, I'll just show it like this. I'm going to use these 2, all right? And I'm going to just add up those 2 equations, and then my y's will eliminate, and then I'll have an x and a z. Now, I'm not going to be able to get just x by itself, all right? I'm going to have a z with it, but at least it's a starting point. At least we got rid of the y. Everybody with me on that? No, we're going to use all 3, but right now, for the very first step, we're only going to use 2 of them, okay? So I'm just going to copy and paste this just so I don't have to rewrite it. Too bad you can't do that on your own paper, but that's okay. All right, so what I'm going to do, I'm not going to mess with anything. Already, it's set up perfectly for us to get rid of the y's. Would you agree? So I add up all the columns. So I add up the x's, I add up the y's. When I add up the y's, they'll cancel out. They'll eliminate, right? That's the elimination. And then, but I'm going to have an x and a z, but then we're going to do some stuff with that. All right, so let's do it. Let's add these columns up. This is 1x plus 3x. That gives me 4x. That's 0. What's this add up to be? Minus z equals positive 4. Okay? Now, that's not my answer, though. I'm going to use that, but I'm going to use it in another step. So what I like to do, you don't have to do this, but I do it. I like to hang on to it. Even in my notes, I put them in a little box right there. All right? So I just put it in a box for safekeeping. I'm going to come back to it and use it later. Everybody good so far? Yeah. And again, like I said earlier, they rigged this thing super, super easy for you. They're not all this easy, all right? But you'll get the basic idea of it with what we're doing right here. Now, I have an x and a z. It'd be really, really nice if I could do something over here so I get another equation with an x and a z, and then I'll have 2 equations with 2 variables, right? And then I can solve for that. And that's something that we've definitely done before. Everybody got it? So what am I going to combine now? Before I did the first and the second one. Yeah, let's do the second and the third one. All right, you can do that. Now, if you wanted to, this would be an extra step. If you wanted to, you could do the first and the third one, but then you'd multiply the bottom one by a negative, right? But why bother? You already got a negative and a positive right here. Agreed? So what I'm going to do is I'm going to copy. Oops. I think I grabbed that. There we go. I'm going to copy and paste that, move it down here. And we're going to do the same thing that we just finished doing with the first and the second one. Now we're doing the second and the third one. Again, I'm just warning you, they're not always this easy. This is the easiest version of this problem that you'll probably do. All right, we don't have to mess with anything. It's already set up for us to eliminate the y's, so they'll eliminate, add up everything else. I get a 5x. What do I get here? A 5z. And I get, what's that, 30? Okay. Now, you could combine this equation with this one, but I see something right away. You don't have to do this, but I saw it and I did it, and I think it makes it a little bit easier. What do you see? Yeah, I would do that, okay? I would divide everything by 5, all right? So you could factor out, then divide, or just divide everything by 5. Would you agree? Because 5's in common with everything. Just make it a little bit easier, right? So let's do that. I don't even know if the book did that. I didn't even look to see if the book does that. But I did it. I think it makes it a little easier. So if I divide everything by 5, now you can't always do that, but in this particular situation you can, and I think it makes it a little easier. So what do I have? X plus z equals 6. and I'm going to put that one in a box. Doesn't mean it's my answer, just means I'm going to use it well, I'm going to use it like right now, actually. Okay, this one I put away for a few minutes, right, while I did this. But now I'm going to use these two right here, all right, and I'm going to put them together. Why can I use these two? Because this has an x and a z, and what does this have? An x and a z, all right? So let me just copy and paste that, put it right there, and then I'll do the same thing to this. And let's put it right here. I'll get rid of the boxes. Don't really need those now. Now look, again, it's like the third or fourth time I said this today. This is rigged, all right? It's not always this easy, but this is rigged pretty nice for you. Look, the z's will cancel out real nice and easy, won't they? Everybody see that? So bang, bang, there they go. 4x plus x is 5x equals 10. Divide both sides by 5. X is 2. So we finally got one of our answers, okay? But how many do we need? We need 3 of them. We got to find y and z. Doesn't matter what order you find them. I would probably find z right away. To tell you the truth, it's pretty much the only thing you can do, I think. All right? Because I could put it in for the x right here, or I could put it in for the x right here. Put it in for the one that you think is a little easier. I think probably this one already has x by itself, or sorry, already has, well, that has z by itself as well. I'd put it into this. This is a positive z. So let's put some numbers in. What do I know? I know x, right? So it's 2 plus z equals 6. Subtract 2, z is 4. So I got 2 answers. Now I got to find y. Where do I go to get y by itself? I could go anywhere where there's a y variable. Okay, it doesn't matter where you go. I'd probably either use the bottom one or the third one or the first one. Which one would you use? I'd probably use the first one. I'm going to copy that. I'll bring this down here. Because that has an x in it. It's got a z in it, right? So I'm just going to substitute in for those. I'm just going to get y by itself. Why did I pick this one? Because it has a plus in front of it, all right? It's a positive y. Just saves me worrying about that negative, all right? It's just a little easier. You could use any of the equations that has y in it and an x or a z, but I think this is the easiest one. So let's plug the numbers in we've already found. We know what x is 2, so we put a 2 right here, plus, what are we solving for here? Y, so just make it y, minus, let's do this in our head. What's 2 times z, or 2 times 4? It's 8, right? Equals negative 9, and then just solve for it. This is negative 6. How do I get rid of a minus 6? Add a 6, and did I do that right? I think I did something wrong. What did I do wrong? I put 19. Why did I put 19? Just seeing if you're paying attention, that's all. You believe me? Yeah, I wouldn't believe me. All right, so y equals what? Negative 3. Now, remember how when we did these before, how did we write our answers? Because really, remember, it was a point of intersection, wasn't it? Well, this is also a point of intersection. All right, this is also a point of intersection with 3 planes. They're not just lines, they're planes. And where do they intersect, okay? Actually, they would be 3 lines. Yeah, they would be 3 lines. And where do they intersect each other? They intersect before, when we only had 2 of them. We saw for x and y. We wrote it as a what? An ordered pair, correct. But now we have how many? 3. So we actually call it an ordered triple. They don't write it like that in the book. I'm not sure why. Most books do. They just say x equals y equals z equals. Right. Do they write it as ordered pair? I thought I looked and, okay, maybe I just didn't see it. But you should write it as an ordered triple. Instead of an ordered pair, because pair is 2, we're dealing with 3, so it's an ordered triple. What goes first? X. So it's going to be 2, and then y goes next, which would be negative 3, and then z goes last, which is 4. So that right there is your answer. These can be a little bit lengthy, I'll tell you right now. Okay, they can go on for a little while.
What do you mean lengthy? Like the amount of steps you have?
Yeah. Like the amount of steps we did today was actually a lot shorter than sometimes they give you, okay? The homework I'm going to give you tonight are fairly basic, but then I'm going to give you one tomorrow on the same exact lesson, and they're a little bit more involved, okay? I'm going to do one more example, though. I'm going to do one more example.
Yeah, on the thing that said Wednesday we had time to class.
Yep.
Or is it Tuesday? Tuesday or Wednesday?
Tuesday.
Tuesday.
Okay, let's do another one. You ready? Everybody ready for another one? This really isn't a whole lot different than what you've done before, is it? Same idea, same basic idea, except you set up, see the things in boxes? You set those up first, and then you go from there. All right? All right, next one. This is example 3. It looks easier because it's a little shorter. Example 3. But sometimes these can be a little bit trickier. This one's not so much. This one's a little bit. So x plus y equals 6. Now look at this. They don't even give you 3 of them. They just give you 2. Right? Well, we're not done yet. 3y minus 2z equals negative 10. Now, could I just use these two and solve for everything? No, because I actually have 3 variables. I got an x, I got a y, and I got a z. So I have to have another equation to be able to solve for all 3 of them. Okay? And they do give you another equation. 4x plus 5z equals 56. All right, so there you go. That's what they give you. And what you have to do is you have to find x, y, and z. Now, it's not set up quite as easy as the first one was, right? There's nothing really in here. You can just add the 2 together and cancel out right off the bat. So there's a couple, and look, this has x and y, this has y and z, this has x and z, all right? So here's how I did it. I didn't even look how the book did it. I just saw the problem, wrote it down, and solved for it. So this is how I did it. Again, the book might do it a little differently. They might do it better. I don't know, but this is what I did. I decided, what's the easiest thing to get by itself out of all 3 of these things? Yeah, either the y or the what? Or the x. Okay, I did the x. It was first, so I just did the x. Okay, so I want to get x by itself. So if I get x by itself, what's that going to give me right here? X equals what? What do I? Plus? Is it y? How do I get rid of the y? I minus it. So it's going to be a negative y. It's not going to be y. Oh, you did? I thought you said y plus 6. Okay, you would be right then if you said negative. You could put the negative first. I just did it like this. It doesn't really matter. Everybody with me on that? So now what am I going to do? I'm going to basically do some substitution. On the other problem, the very first step I did was elimination. I think on this one, I think substitution is a good way to do this. We are actually going to do some elimination a little bit later in this problem, okay, but not right now. So I got x right here. Where else do I find an x? Got one right here, don't I? So I kind of know what x is equal to, so I'm just going to substitute that in for this x right here. So let's just rewrite it. 4 times x. What did I say x was? 6 minus y. If you wanted to put negative y plus 6, that's fine. It'd still work. No big deal. And I got 5z equals 56. All right, let's simplify this. What do I get? 24 minus 4y plus 5z equals 56. Let's do what? Let's keep the y's and z's on the left-hand side. Let's just get rid of the 24. So if I subtract a 24, what do I get? I get negative 4y. All right, I'm not minding. Negative 4y plus 5z. And that equals, what's that? 32? All right, everybody good so far? Now, can I solve for y and z right now? No, because I got 2 variables. I only get that one equation. So what I'm going to do, again, you don't have to do this, but I do it basically just for teaching purposes so you can kind of see it. What I'm going to do is I'm going to take this. This has a y and a z, doesn't it? So do I have another equation with just y and z in it? I do. The second one right here, okay? So what I'm going to do is I'm going to take that and combine it with this one. Okay, see what I did? I knew I ended up with a y and a z, so I looked somewhere else. Do I have anything else with a y and a z? Yeah, right here, y and z. If I wanted to, I guess I could have done a substitution, or I could have got y by itself and then plugged it in for another y. I don't know. That would have been ugly. I think what I'm doing right now is the best way. Okay? Everybody okay so far? No? What's wrong? Now what am I going to do? Let's put another color here. Look what I have. I'm back to when I had the two variables. Am I going to do a substitution here? Nah, because if I solve for y, I'm going to get some fractions. That's going to be super ugly. Now, you could, technically, you could do that. But man, I sure wouldn't. That'd be a pain. So what am I going to do? Yeah, multiply by something, right? So I could either eliminate the y's or eliminate the z's. It really doesn't make any difference. Did you? Well, I did the y's, so let's do it the way I did it. But you could. There wouldn't be any really difference, okay, as far as difficulty, I don't think. Getting rid of the z's. I decided to get rid of the y's when I did it, so let's do it that way just so I can stick with my script here. All right, so what am I going to do? I got to turn this into something, this 3 and 4. I need to turn it into a 12. So what do I multiply this by? A 4. So I multiply this whole left side by a 4, and then I multiply the right side by a 4. In order to make this a 12, what do I have to do? Multiply this by a 3, and multiply this by a 3. Again, this is old stuff. This is really nothing new. It's just we're taking that stuff and we're just expanding it a little bit, just doing a little bit extra with it. All right, let's write it out with everything being multiplied by 4. So I have 12y. I got minus 8z, or yeah, that's right, 8z equals what? Negative 40? Is that right? Negative 40? I'm doing the top, not doing the bottom. That is what the bottom would be, but it's not the top. Let's do the bottom. This is going to be a negative 12y. It's what we wanted, right? We wanted the same thing, plus and minus, so they can cancel out. And then I got negative, what? Or it's plus 15z. And that's what? 96. Good. All right, now we're back to elimination. So those eliminate, they go away, they cancel out. This is what? 7z. And this is 56. Divide both sides by 7. What's 56 divided by 7? That would be 8. So there we go. We got one of them. Once you get one, it's kind of like dominoes, isn't it? Push one and the rest just boom, 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 boom. They just go down. All right, so we got one. That was the hardest thing out of the whole problem. Now, what do you want to solve for? You have z, so you have to use one with a z in it. So I could use the second one, or I could use the third one. No, we don't have x. We don't have. All we have is z. You could use the second or the third. For some dumb reason, I use the third one. Looking back on it right now, I probably should have used the second one, just so I don't have to deal with a big number. But really, that big number is not going to bother me. Does it bother you? Does it? 56? Right. All right, so here's what we're going to use. All right. Oops, let me click off of it. There we go. All right, so let's put the stuff in. I know what the z is, so this just stays 4x plus 5 times z, which is 8, equals 56. All right, so I got 4x. Let's do this in our head. That's going to be 40. Subtract a 40. What's that going to give me? 16. X is 4. There we go. So I got 1. I got 2. Now I got to find y. Well, look, I got a y right here. If you wanted to, is that... You could have used the first one. Yeah, that'd be pretty easy, wouldn't it? Let's do that. Let's use the first one. So what did I say x was? 4. All right, so let's come up here. So it's just 4 plus y equals 6. Subtract a 4. That's really easy. That's 2, and there's our 3. But we write it really nice. So how do we write it? As an ordered what? Triple. What was our x? 4. What was our y? It's off screen, but what was it? 2. And then our z is 8. And that is the answer. So what does that mean? 4, 2, and 8. That means I can put those numbers in here and everything should work. All right. What was it? 4, 2, 8. So what's 4 and 2 is what? 6. That works, doesn't it? And you can do the rest. You can plug them in and they should. The left side should equal the right side and you should be good to go. What do you think? Hopefully you took good notes on it. Hopefully this will record. I don't know if my first two, I had problems with the projector. And then I was trying to mess around with something, then the computer froze up, so I don't even know if I was able to record my first 2 math classes today, but I haven't even looked yet to see. But I switched a part out. You know how it would fade in and out sometimes? Then I'd get all frustrated. I was crazy frustrated today. But thanks to Mrs. Millette, you know her? She's the computer teacher.
Oh, yeah.
So I asked her, I said, you wouldn't have this adapter thing. She says, yeah, I got a couple of them. I'm like, yes, amazing. So I switched and it seems to be working. So I hope it works. So that was very nice of her. All right. What's your homework? 10 to 17. So we're going to call it 3-6A. Bring me a pass. So it's 3-6A and you are doing 10 to 7. Did I say 17 or 16? 17. All right, so 8 problems. Can't complain about doing 8 problems. All right, everybody good? All right, you got time. You got like 20 minutes left in class, all right? So get them half done in here, and then you only have half of them to do at home. All right, that's all I got. Get it done.